Good morning, everyone. We were reviewing the Blackboard implementation. So in the previous lecture, we finished with a draft of the class diagram, something like this. You help me with ideas about the Blackboard, one class, student, professor, the expert, and the controller probably need to implement, runable the class in Java. You do a research about that for adding concurrency to the objects. So in this idea of the Blackboard pattern, one repository for the information that can be in one class. That class could be responsible for providing the data structure and the methods, the interface to access that data structure. Then you have two classes, a student, professor, or whatever name you want to use, that are implementing runable. Therefore, they are going to be able to run at the same time. The main method in those classes, the one that you need to override, as is common with the interfaces, is a method run. You know about it. So you can put what is the equivalent to a main, the instructions that you want those two to be doing, and they are going to be working in that method run. Obviously, they are going to be connected with an association with the Blackboard, because the goal is that they are using the Blackboard. They are not connected between them. There is no communication between the expert and the leader, the student and the professor. And then we need a class for the main of the full application. Among other things, the main is going to be, as usual, the one that create the actors in the software. The main is the one that need to put together these two or these three. And somehow the main is the one that is going to put the order, give the order to them to start working. So there is going to be some kind of connection between this class that have the main and student and professor. I do not know if Blackboard also, but at least with the student and professor is for sure. Moreover, according with the architectural pattern, you have only one professor, one leader. You can specify that in the class diagram with this number one, and you're going to have more students, several students, an asterisk in the class diagram. And one thing that I want you to notice is how different is the design, the class diagram, software design, versus the software architecture. The diagram that we show with this Blackboard at the center and all the boxes around and these arrows bidirectional. The arrows bidirectional in the software architecture are related with this idea of the communication, the interaction between the Blackboard and the actors. Here, the arrows, in particular, these two, something important to remember is they have a meaning, and is the meaning that UML define. These arrows here are not bidirectional. These arrows there represent that the student and the professor are calling methods from the Blackboard. That method can be a getter or a setter, it doesn't matter, but these are calling method in Blackboard. And therefore the relationship association is from the one that is using something to the one that is being used. It's not about the flow of the information. It's not about this one pointing also back because it's sending data. Be careful with that. Okay, so moving forward, if this is the diagram, the next step is source code. And I just want to be sure that we agree in the implementation. Again, a very draft implementation for the Blackboard pattern. Number one, classroom. You can start top down or bottom up. Here, top down. If I open my developer environment, if I start doing this program, according with this, I am going to start in that direction. I am starting with the main. If I start with the main, the first thing that you notice is there is no global variables. There is no global variables. Why? Because according with the diagram, the only connections that I am using with the main are these lines with the arrowhead. There is no diamonds. If there are no diamonds, no global variables. If there are global variables, you should use diamonds. That is the connection. That is the meaning of the diamond and that particular connection in UML. So no diamonds, no global variables. Method, main, everything is local. Now, everything is local, and this is from the Runnable tutorial. You create student. I am going to create two, and professor. Notice that I am using a student and professor. Student and professor. Those are the things that I am going to use. In particular, I am going to call methods from them. Now, student and professor, in order to create all this idea of concurrency, you create the Runnable. They are going to be implementing Runnable, and you put them in a new thread. And then you ask the threads to start. And that is the only thing for the main. Create the users, students, create the professors, run. Here, one decision could be inside, create the Blackboard, and then share the Blackboard with these guys, maybe as a parameter. That is option one. The main, create the workers, and also the resource, and then connect them. Connecting them, parameters. The solution that I am going to use here, a little bit different. Instead of having the main, creating the Blackboard, because we know that the Blackboard, this space to share data, is going to be unique. Only one for everyone to use. In that point, only one singleton pattern. We can do Blackboard, a singleton. It's going to be unique. There is going to be only one Blackboard. I am going to have the class Blackboard only to create one for everyone to share. If I take that decision, if I am going to create the Blackboard as a singleton, I do not need to create the Blackboard in the main. The Blackboard is going to be created the first time that someone tried to access, and I am going to show you. So classroom, 2 students, 1 professor, and ask them to start working, period, done. Moving forward, if I am using the class student and the class professor, I need to define those classes, my classes. Notice that I am sending as a parameter here a number. It's useful if I am creating several students, give each student an ID. So later, for something that I do in the program, I can ask a particular student, the one with a particular ID, to do a particular action. It's useful. The professor, I am not sending any ID to the professor. Remember, I am calling a constructor, and I am going to create that constructor. So you take the decision, I take the decision of adding parameters or not to the constructor. For a student, I am adding the parameter. I need to identify the different students for something. For the professor, it's going to be only one, so nothing as a parameter. Students and professors. Moving to the professor, that is the easy one. And you can notice no variables. I do not define IDs. I do not have any particular job for the professor to do, but if you need it, if something here need variables, well, as you know, this is the space. Also methods, you can add more methods, but the important one here, because I want to use concurrency, is number one, this class is going to implement the interface Runnable. Runnable is part of the package Java Lang, so it's available for you to use in any class without any particular import. Implement Runnable, and then override this method. And as I mentioned before, this method becomes the main for the professor. It's the method, the actions that this class is going to start doing when I create the object and I ask the object to start. The start that I put here, what it's going to do, among other things, is to call. This start is going to call this run. So when I call the run, and as you can notice, what I did here is an infinite loop. Infinite loop. Without the concurrency, this infinite loop will stop the rest of the program. But here, the program can be doing other things. Here, I am in an infinite loop for the controller. Infinite loop, the only thing that I am doing, and here, obviously, is the space for you to do more interesting things. Calculate something, search for something, review something, get data, return data, and so on. But in this point, the only thing is printing things. Printing things used for you to know that this is working. How many times these things are going to be printed? Forever. And something useful when you're working with this, ask the thread to sleep. Sleep, because if you do not send this one to sleep, well, it's going to take the control of your CPU. It's going to be running forever. It's a good idea to ask the thread to do something, then go to sleep, 1 second, whatever. And while this one is sleeping, the others have the opportunity to work. Remember, concurrency, depending on the hardware, is the fact that they are really running in parallel or really they are running concurrently. Concurrently, when one stops, the other use the CPU, and then this one, so it's only one resource and they are sharing that resource. Anyway, it's a good idea to ask to sleep in some point each of your threads. This one, printing, working. This one, the student, similar implementation, almost the same. Runable, and the run. Wait, for this one, I want to send an ID. I want them to have a particular variable to identify them. Your variable, and for this one, you need a constructor that is not default, a constructor that receives the value and store the value in the global variable. So your constructor is called, the value is stored, and then when you ask this to start, the method run is executed, and this one is also an infinite loop. All the students are running an infinite loop. The controller is running an infinite loop. So each of the boxes in the Blackboard pattern is a process, a program running, and all of them are running infinite loop, are there forever. They go to sleep. So this is sleep, the other work, and so on. The operating system is going to take care of the concurrency. Similar, a message. And here, I want you to notice that line, the 12. What happened there? I haven't created yet the class Blackboard, but just because the previous knowledge that you have, when you read that line, it's like, well, Blackboard should be a class because it's not an object here. Dot get instance. That get instance, just because I am using the same name that in the pattern, immediately should bring you the memory of singleton pattern. You are getting access to something that is a singleton, and that something is the Blackboard. I didn't pass the Blackboard as a parameter. I didn't need to pass the Blackboard as a parameter because it's a singleton, and I can have access to that used with the name of the class, get the instance, done. And you can imagine that here, I am using a call to a method in the Blackboard, right? And in this particular case, my object students, all these experts, what I am asking them to do is, like crazy, forever, sending data to the Blackboard. I am not solving any particular problem, just to show you that it's possible. Writing, and something that is common is, well, What about if every single time that you put something in the whiteboard, you as a student pass and write something, you add your ID so everyone know and remember who put that angle. That is something very, very common. So my write method could be 2 parameters. The first parameter is the ID of the student. The second parameter is whatever data the student or this expert want to put in the Blackboard. Always 2 elements. Because both elements are in the Blackboard, I can get the results as an expert, as a professor. And if for any reason I need to know who created that result, I can know also. Go to sleep. And this is going to be happening forever. Only random numbers, again, is all about adding more source code there, maybe more methods, doing something more complicated. This is just to show the structure, the skeleton. So student, and if I go to Blackboard, and I already mentioned like, okay, you're going to have the Blackboard is going to be the data structure, but it's going to be a singleton. When you mention or when you know that it's going to be a singleton, there are some elements that you should remember to add. There is no inheritance or implementation involved. It's just a class. It should have the data. You should decide here which data structure you're going to use. Students and professors are going to be accessing this data structure. What is the data structure that best fit for your problem? It's going to be a map, it's going to be a linked list, a vector, use an array. You need to remember dynamic memory, static memory, dynamic access, sequential access. What is the data structure that fit for your problem? You take a data structure class so you know pros and cons of the different options. Here, just for the example, this, I need to be clear, is not mandatory to use a vector. I am using vector use as an example. Here, you need a data structure, the one that fit for the solving of the problem. So a vector, data, but also because I want to implement singleton, I have this one, the instance. Remember, right? Private because it's a variable, static, the same name of the class, and any name. Any name, if you follow the pattern, if you want to make this clear for every reader, instance is the name, whatever. A constructor. Important thing for the pattern, the constructor is private, but at the end it's a constructor. What I am doing, initialize the data structure. For my example, a vector with 10 elements. For my example, I have 2 students. Both students are going to be working. I just create one space for each student. That's it. Obviously here, something more complicated, more complex, depending on your problem. Yeah, here, something very, very important. My example is considering, and you're going to notice this, that the student that have the ID 0 is always going to write in the position 0. The student that have the ID 1 is always going to write in the position 1. So in this particular example, I am assuming that you have the whiteboard, and I split the whiteboard in several different zones, and to each student, I am giving one zone, one space. So there is no concurrency problems. There is no race condition things. The Blackboard, the method in the singleton, get the instance. The source code for this 13 to 17 is copy paste of the pattern, really. And read and write. That basically are delegates, connections for the add and get methods in vector. This is just the adaptation of the method that you want to call, read, write, and whatever is the name of the method in the particular data structure that you are using. If you use a stack, it's going to be push and pop. If we're using vector, well, add and get, whatever. But for the user, it's just calling read and write. Separate the interface of the data structure and the interface of the Blackboard. The users only need to remember the interface of the Blackboard, don't care about the data structure. This is the whiteboard, the Blackboard, the student, the professor. And with that, we can go back here and classroom connected with the student and professor, yes. Student and professor runnable, yes. Blackboard use connected with the student and professor without connection with classroom, yes. This is my class diagram. This represents the source code that I showed you before. The only thing that needs to be done is obviously we need to put here, important here, the methods and the variables that we are using. For this one, we do not need to put anything. It's from the library. Classes that are from the library, the only thing that you need to show is the rectangle with the name. You do not need to add all the methods and variables. What you need to show in your class diagram is your methods and variables for the classes that you are creating. It's a blueprint of your system, not a showcase of the libraries. So these 4 classes, add the methods, add the variables, according with the source code. The runnable is used, that box. Another thing is you do not need to use here the class vector. You can tell me, oh, here, this data structure is a vector. Usually what you're going to do with those classes that are used containers for data types, you can, if you want to show me that this is a vector, you can put vector as a type for this variable. That's it. It's not common. It's not needed to have something like a diamond here and the connection and the class vector. No one cares about that. You're using a vector. Good. It's used enough if you put this. It's important that you show runnable because that is meaningful for your problem. Having runnable there is telling the reader that these are threads, that concurrency is involved. This, you can avoid it. Something that is important is abstraction. You think about that in programming, but you should consider that also with the diagrams. Your diagrams should be abstract enough. Remember that picture of the cat from the book. Your diagram is that picture. You need to show in the diagram those ideas that you want to share with your programmers. You are doing the design, someone else is going to program this. So what is important for the programmer? If I put use vector here, my programmer is going to understand. My programmer needs to know that there is a diamond with vector. Hopefully, most of your programmers are going to be fine with that. But this is a box. Take the decision of where to show the class and when used to put a data type. It's a decision for designing for the class diagram. Anyway, the diagram, very different from the architectural one and the source code. Review this. You're going to do an assignment and you're going to need to use this. So be sure that all this is clear. Moreover, if you can copy, paste, and run, that could help you. Moving forward, this was Blackboard. Next one, the last one, client server. Client server is another common architectural pattern. Client server is for sure something that you know. You have a network. In the book is internet, but it uses a network. You have access to a local area network or to something like the internet, whatever. And you have 2 programs running. This is one pattern that is not about subsystems, but about 2 systems working together. One of those systems is going to be called the client, and the other one is going to be called the server, client server. Both are connected via network, but they are really 2 different systems. 2 different systems. Yeah, my ASU is one system. All the system that is in the servers of the ASU university. The client is your browser. In fact, if we talk about web application, this client is your browser. Your browser is the client for several different services. My ASU, Amazon, Facebook. Your browser is your client. The server side is the company providing a service. The same model you can use for several different things of software. Most common of them, if you think about cloud computing, if you think about having a client in your home that is basically checking your refrigerator or the temperature in your room, it's a client, it's a piece of software that is reading some kind of sensor, sending the data to the net, using the network to connect with another piece of software. That other piece of software, a server. That server is another program. Can we develop a server? Yeah, you can do a Java program if you want to use Java. The only thing that you need is a hosting, a place to put that software that is running 24/7. And this guy need to know the address for this particular service. And if you know the address, you can establish a connection. The address. Yeah, if we're talking about networks, and it's something that hopefully you learn in a different class, but the address, basically we're talking about an IP address, these numbers, right? And a port. Numbers. If you have the IP address of the server and you have the port number in which some service is running, you can establish a connection. What happens if I have a name? If you have a name like asu.edu, that is a DNS name, is a word, but that one is equivalent to a number and therefore to a particular port. If you're using the web, your port 80 by default. You can change it, obviously, by default, 80. And other services have ports by default. If your client knows that, establish a connection. Okay, good. Examples. The model, client, server, the network, easy. What if I want to create an application following this pattern, following this idea? Well, advantage and disadvantage first. Obviously, this is great. This is the core of distributed systems. This is the core of having one piece of software, but instead of one program running in one computer, you have different programs working together in different hardware, different computers, and they do something in a collaborative way. Similar to the Blackboard, big problem. One point of failure. Which one? The server. My ASU, if something happened with the server, all the students, even if your browser is working, your browser cannot show you your classes or Canvas or whatever if the server is down. One point of failure. The server become like the Blackboard, the source of the information. Now, another point of failure, the network. You have an exam, your internet provider is failing, you cannot take your exam. You depend on the network, you depend on the server. Anyway, we need to improve this, we need to be careful with this. The model, the advantages are worthy. Source code. I am going to do the opposite that previously. I am going to show you first the source code, and then you help me with the class diagram, because we need the architectural diagram, very fancy draw. We need the class diagram, next step, and finally the source code. Here, just because it could be the first time that you do a program with network element, socket, I ask you to review that. Let's review the source code, understand what happened in the source code, then we go back to the diagram. Source code, the simple server that I can have and the simplest client that I can have. So let's think about this client-server application in which my client is going to be only one class and my server is going to be also only one class. And then These two classes are going to be one program, another program, and they communicate using the network. Key idea for the client-server pattern. Server, only one method, main. Inside of main, I create an object from a particular class that comes from this particular package. You read about it. This object is the one that is going to allow other programs, the clients, to connect with this program, the server, a server socket. I do not need to worry about how to do a network connection. I do not need to worry about the TCP protocol or HTTP protocol or whatever. The only thing that I need is an object that do that work for me. And that object is server socket. Class diagram. I have my class, my server. I only have the main method according with this. And I am going to be using a server socket. Server socket and my server. These two guys are going to be connected. Which is going to be the connection? Composition, aggregation, association, realization, inheritance. What is the connection between my server and server socket according with this source code? Hopefully you agree with me. Thank you. Association, the arrow. No diamonds. There are no global variables. There are no attributes. Obviously, inheritance, realization, and so on, nothing. Class, my server, no inheritance, no implements. My server is using server socket. Well, I can comment about that. My server connected with server socket is using that one. Using server socket, that's it. When you read the class diagram, you will notice that if some part of the system is connected using server socket, that part of the system is a server in a system that there is going to be another class diagram for your client. Your system is a client-server application. The one that have the server socket, you are describing the server part. And you can have one or more clients that can work with this server. It's like having an application that is web, but also can be a mobile application. So it's the same server. It doesn't matter if the connection comes from your cellular or from your computer. The server is going to do the work. It's going to send back data. And the clients are the ones that are going to choose how to show the data according with the different interfaces. That's it. No, quick comment about the names. Two things, guys. What do you think about using X and Y in the software? You think that that is meaningful or not? And for some people, it could be like, no. But if you think a little bit, X and Y have a lot of meaning in math. If you're working with algebra, X and Y are meaningful. Moreover, if you work with uppercase A, B, or if you work with I and G, for some people, in some contexts, it could be meaningful. But if you're working with matrix, this is something that everyone understands, or the uppercase name for the particular tables, for the index. The meaningful thing is all about the context. So one recommendation is be careful. You can be meaningful. You can have some name that is okay, like A, X, Y, E, J, A, B, depending on the problem that you are solving. depending on the software that you're doing. Obviously, if, for instance, we're working with student, like a CS110 name, and the name for your student is X, well, this probably is not meaningful. What is X as a name of a student? So this could be wrong. But if you have an integer X, and what you are doing is an equation like a square root of X plus 1, etc., probably this variable X is just fine. It's part of an equation, it matches the description. The context is very, very important. Moreover, in the second level, if you are looking to my source code, this is from the book. If you look in examples in the book, when you look to software like this, a small piece of software that is showing you how to use something, it's not a software that you are going to deliver to a client. It's just a small piece of software that you are using to show something, to explain something. It's very, very common to have these things. Why? Because you do not want the reader to be distracted with the names. You want the reader to focus on the name of the classes, the name of the data types. Again, the source code is not mine. It's a copy paste for a book, but it's very, very common that you are going to notice these names when the book, when the author, when the example is about explaining you for the first time how to use something else, where the focus of your attention should be in .NET asterisk, for instance. The context is important. Good. So my server is going to have a server socket, and this instruction here is the important one. That instruction there, this instruction about accept a connection, the instruction for waiting and waiting until someone gets connected with you. You can think about that in this line of the source code, your program is going to stop. And your program is going to stop, and it's going to stop to wait a client to connect. That's it. You can imagine that inside of that method, there is a loop, and the loop is running until someone connects. And what happens when someone connects? This method is going to give you a socket, an object socket. I am going to talk more about the socket, but it's going to give you an object with all the data for that connection. All the data. You do not need to worry about all the data. The only thing that you need is to use this object that you receive from the connection, call a particular method, and extract from that object another object. Really? Yeah. That other object is the one that you can use for communication with the other piece of software. You can communicate using binary streams, or you can communicate using text, sending letters, sending bytes. Both options are available. In this example, I can do read or I can do write. This thing that I get here is my channel of communication in which I do not need to worry about the technology. I do not need to worry about what is happening. It's like these lines set up a phone call between this software and the other software. And whatever I put here in this side of my line can be sent, write, or I can get whatever the other do, read. And I can be, for instance, printing or doing something with data that I am getting from my client. And my client could do the same with data that is getting from me. Read and write. Those are my instructions, the important ones. And server socket, socket, and some kind of stream, input stream, output stream. Those are the things that I am going to need to create these connections for reading or for writing. That is in the server. What about the client? For the client, no variables. Also one method. Try and catch. Try and catch. I do not need a server socket. I need a socket. I need a socket. And in the socket, because I am the client, I am the one that want to connect with the server. As a client, I am the one that need to know the address of the server. The address of the server, the port, and the IP. Localhost, my computer, remember, your computer is your localhost. So if you run your server and your client in your computer, both of them, localhost is your IP, your address, and the port, any number, well, it should match with the port that the server decides to use. In this case, the example is using that number. So that is the port that the server is using in whatever computer the server is running. When you want to access, which is the computer, which is the port, and you are trying to do a connection. After doing that connection, next step, similar to the previous one, from the socket, the stream, from the stream, in this case, write, but you can also do read. And use like with files, flush, to put everything in the file, well, in this case, to send everything to the net, and close when you finish. This client, the only thing that it's doing is connecting to the server. Once it gets the connection, send a message, hello, and finish, close. You can imagine that you can put here a loop. Having there a loop, you can be writing the server several times, or you can imagine that you can do a connection every time that you finish doing something. So you send results constantly to the server. The server is receiving this data. You can assume that the server can connect back with you. The classical application with this is a chat, like the chat that we have here, sending data, receiving data. You have a socket in your side that is receiving my comments. I have a socket in my side that is receiving the comments. Well, here we are talking about a server that is working with TCP/IP locally. If in particular you want to use the HTTP protocol, Java gives you a class, URL class that work with the HTTP protocol. The other idea is that you can work with sockets, TCP, and it's going to be your responsibility to add the elements of the HTTP protocol. So for instance, sending a message, and the message should start with this get or put, the idea with the HTTP, but you can use the URL object, and then you have also similar working data socket, but the URL class is going to provide this getter, put, and so on. So you can communicate with an HTTP server. Similar idea, what is going to change is the protocol. You implement the protocol manually, or several libraries, like the libraries in Java, are going to provide you classes, particular classes, specialized with particular protocols. You have WebSocket also, that is more for Internet of Things applications, several different protocols there, better than HTTP or TCP to sending data from sensors, for instance. So my example is use a trivial common TCP connection. That's it. URL could be better for HTTP. Others, there are several available, including WebSockets. So this is the server, this is the client. The question is the class diagram. What is the class diagram for this example of client server application? What is the class diagram for this and this? Moreover, we're talking about two class diagrams, or is only one? They are connected or not? There is association. Do I need to put socket or data or the network? I want you to think about it, and we continue with the diagram next lecture. Any question? Nothing? Good. See you Monday. Thank you.